Hi class, this is our review for our Chapter 5 Part 2 test here in Advanced Algebra. So the first section is breaking down radicals. We can't take the square root of 48, but we could break it up into 16 times 3, and we can take the square root of 16. The answer is 4. So 4 square root 3 is the answer for question number 1. 90, same thing. We can't take the square root of it, but we can at least take the square root of 9. The square root of 9 is 3, and the square root of 10 is multiplied by it. So 3 times the square root of 10. Number 3, remember a to the 7th times a to the 7th is a to the 14th. So the square root of a to the 14th is a to the 7th. Basically, you just take your exponent and divide it by the index of 2. So we take 8 divided by 2, and it's a to the 4th. And 4 divided by 2 is b squared. The square root of a to the 8th, b to the 4th is a to the 4th, b squared. Number 4, the square root of 9 is 3. The square root of x to the 6th is x to the 3rd. The square root of y to the 8th is y to the 4th. All those exponents you just divide by 2. On this one, we could break down 50. It is 25 times 2. So the square root of 25, the 5 comes outside the radical, but the 2 has to stay underneath. Now this a to the 10th, the square root of that is a to the 5th, so a to the 5th comes outside the radical. The b to the 7th, remember when it's an odd exponent, you divide it by 2, and it's 3.5. So you can take out 3 b's, so you can take out b cubed, but there's still 1 left underneath the radical. The numerator represents what's left under the radical. So there's b to the 1st left, and then this c to the 8th, the square root of that is c to the 4th. So there's the correct answer for question number 5. Number 6, you could take the square root of the numerator. The square root of 25 is 5, and take the square root of the denominator, and that is 6. So 5/6 times 5/6 is 25/36. So the square root of 25/36 is 5/6. Question number 7, we could break up 20 to be 4 times 5. So the square root of 4 is 2. That comes outside the radical. 5 has to stay in the radical. Once again, we have an odd exponent. So if we divide it by the index of 2, 7 divided by 2 is 3.5. So we can take out n to the 3rd. The whole number represents the exponents that come out of the radical. Then this numerator is the amount of n's that are still in the radical. So n to the 1st. 2n cubed times the square root of 5n. Question number 8, when we add and subtract radicals, the radicals have to be the same in order to add and subtract them. So 27 and 12 are not the same radical, but we can break 27 up into 9 times 3. So it's 3 root 3. And we can break 12 up into 4 times 3. So that would be 2 square root 3. Now that we have square root 3 and square root 3, we could add or subtract their coefficients. 3 minus 2 is 1 square root 3. 1 square root 3 or just square root 3. Same thing here for question number 9. You break this down into numbers that you can take the square root of. 25 times 2 and 100 times 2. So the square root of 25 is 5, so it's 5 root 2. And the square root of 100 is 10, so 10 root 2. Now that you have your radicals as the same, root 2 and root 2, you could add their coefficients. 15 square root of 2. There's the answer for question number 9. Question number 10. When you're multiplying radicals, you take coefficient times coefficient, which is just 1, and then you take the radical times the radical, and you get x raised to the 11th in the radical. Excuse me. So the square root of x to the 11th, you take 11 and divide it by 2, the index. You can reduce this to being 5 1/2. So you can take out x to the 5th. X to the 5th comes outside the radical, and there's 1 left inside, the square root of x to the 1st. There's question number 10. Question number 11, same thing. Coefficient times coefficient is 1. Radical times radical is x to the 16th. So it's the square root of x to the 16th. And the square root of x to the 16th is x to the 8th. Just divide by 2. Number 12, same process. Coefficient times coefficient is 1. Radical times radical, 36 is 12 times 3. x to the third times x to the second is x to the fifth, and y to the third times y to the third is y to the sixth. So we have the square root of 36 x to the fifth y to the sixth. The square root of 36 is 6. The square root of x to the fifth, it's an odd exponent, so you divide it by 2, and you get 2.5. So you can take out x squared, and there's still 1 x left under the radical. You can take the square root of y to the sixth, you divide it by 2, and you get y to the third. Number 13, when we multiply these binomials together, we do the first times the first, the outer two terms, the inner two terms, and the last, FOIL. So first times first, 3 times 2 is 6. Outside, the 3 times the root 2 is the 3 square root 2. Inside is root 5 times 2, which is 2 square root 5. And the last times the last, root 5 times root 2, is the square root of 10. We would simplify if we could after this, but there's no more simplifying that we can do. Root 2's could only be added to other root 2's. Root 5's can be combined with other root 5's, and root 10's can be combined with other root 10's. We can't all add those together, so we keep our answer just like that. Number 14, when you have a fraction inside a radical, it's easiest if you could reduce the fraction first. So 3/27ths, you could reduce that to be 1/9. N to the fifth and n to the seventh. If you have 5 n's on top and 7 n's on the bottom, that leaves n squared in the bottom. 7 minus 5 is 2. So now we have the square root of that. So now we can take the square root of the numerator. The square root of 1 is 1. The square root of 9 in the denominator is 3. The square root of n squared in the denominator is n. 1 divided by 3n. For 15, once again, if you could reduce the radical, you should. You take coefficient divided by coefficient, and you can reduce the radical divided by the radical. Each of these you can divide by 3. So that would leave the square root of 36 over the square root of 25. So the square root of 36 is 6. The square root of 25 is 5. So 6/5 is the answer for question number 15. Number 16. When you rationalize the denominator, a lot of people just want to do this. You can't do that. You got to multiply both top and bottom by whatever the bottom radical is, which is the square root of 3. So in the denominator, we have square root 3 times square root 3 is 3. Now you have no more radical in the denominator. In the numerator, you distribute. So 2 times the square root of 3 is 2 root 3. And a negative root 3 times a positive root 3 is a negative root 9, or a negative root 9 is a negative 3. Root 3 times root 3 is 3. This is our answer for question number 16. Number 17, when we have a binomial in the denominator, you got to multiply by what's called the conjugate. So square root 5 plus square root 7. Square root 5 plus square root 7. So when we do that in the denominator, you can do the first times the first. Root 5 times root 5 is 5. The outside term is root 35. The inside term is a negative root 35, and those always cancel out. That's the beauty of conjugates. And then the last term, a negative root 7 times a positive root 7 is a negative 7. So that's in the denominator. It's 5 minus 7. In the numerator, we got to FOIL that. First times the first. Root 5 times root 5 is 5. Outside is root 35. Inside, root 7 times root 5 is root 35. And the last, root 7 times root 7 is 7. So now we just have to simplify all of this. 5 plus 7 in the numerator can make 12. 1 root 35 plus 1 root 35, when the radicals are the same, you add their coefficients. So that makes 2 root 35s. And all of that is divisible by 5 minus 7, which is a negative 2. So oftentimes people want to leave their answer at this step, but you should reduce if you can. This is divisible by 2, this is divisible by 2, and this is divisible by 2. So it's 6 plus 1 root 35 divided by a negative 1. So I would accept this, or sometimes if you just want to do 6 divided by negative 1 is a negative 6, and root 35 divided by negative 1 is a negative root 35. And then it's over a positive 1, so I will accept either of these two answers on your test tomorrow. All right, when we solve radical equations, what we got to do is we have to get rid of the square root by doing the opposite. The opposite of the square root is squaring it. So we got to do that to both sides in an equal sign or in an equation. So the square root of y plus 5 squared is just y plus 5. And that equals 16. Subtract 5 from both sides to get y all by itself. So y equals 11. These are the ones where you can get extraneous solutions. It is possible. So we would have to check our work. We would say the square root of y plus 5 equals 4. And we would want to put y, which we got to be 11, in there. So the square root of 11 plus 5 is 16. Does that equal 4? The square root of 16 is 4. So yes, it checks. So we know that y equals 11 is our answer. Here comes number 19. We want to get this radical all by itself. So first, let's kick that 3 over to the other side. So we have the cubed root of 5x plus 7. That equals 2. Now we're going to cube both sides to get rid of the radical. So when you cube something that's been cubed rooted, those cancel, and you just get 5x plus 7. And then 2 cubed is 8. 2 times 2 times 2 is 8. Continue solving. Subtract 7 from both sides, and we get 5x equals 1. Divide both sides by 5, so x equals a fifth. Again, you should check these for extraneous solutions. The cubed root of 5 times x plus 7, adding 3 to that, equals 5. And we got x to be a fifth. So 5 times a fifth, or a fifth of 5, is 1 plus 7. So the cubed root of 1 plus 7 plus 3 equals 5. So it's the cubed root of 8 plus 3 equals 5. The cubed root of 8 is 2 plus 3 equals 5. 5 equals 5. It checks. So 1/5 is indeed our answer. Here's for question number 20. We're going to square both sides. So we get x plus 2 equals 25, because the negative 5 times negative 5 is a positive 25. Subtract 2 from both sides, so x equals 23. We would check our work here. I would say the square root of 23, the square root of 23 plus 2 equals a negative 5. So the square root of 25 equals a negative 5. So does 5 equal a negative 5? No. So you would cross this out, and you're going to put EXT, which stands for extraneous solution. There is no solution to number 20. 21, when you have a radical on the left side, you get rid of it by squaring it. Whatever you do on the left, you have to do on the right, which works out nice because then it gets rid of the radical on the right. So 5x minus 3 equals 4x plus 5. So subtract 4x, add 3, so x equals 8. Let's check our work. 5 times 8 minus 3 underneath the radical. That equals 4 times 8 plus 5 under the radical. 5 times 8 is 40, and 40 minus 3 is 37. So the square root of 37. 4 times 8 is 32, and 32 plus 5 is 37. Square root of 37 equals the square root of 37. Checks out. X equals 8 is our answer. Getting to imaginary numbers, whenever you have a negative underneath the radical, you can take out an I, because it's a positive 169 times a negative 1. So the square root of 169 is 13. The square root of negative 1 is I. So whenever you have a negative underneath the radical, you can take out an I. 23, this one's a positive 25 times a positive 2 times a negative 1. The square root of 25 is 5, so that's gone. The square root of negative 1 is I. Whenever you have a negative underneath the radical, you can take out an I. Square root 2 cannot be taken out of the radical. 24, when you multiply imaginary numbers together, coefficient times coefficient, so negative 3 times 4 is a negative 12, and I times I is I squared. Remember, I squared is the same thing as a negative 1. So whenever you see I squared, you can change it with a negative 1. So it's a negative 12 multiplied by a negative 1. The answer is 12. 25, let's reduce this radical. It's I times a positive root 5. If you take this into 5 times negative 1, the square root of negative 1 is I, square root of 5 stays. Same thing here, it's a positive 8 times a negative 1. So it's multiplied by I square root 8. Now we're going to multiply. I times I is I squared. Root 5 times root 8 is root 40. I squared is the same thing as a negative 1, so it's a negative 1. 40 is the same thing as 4 times 10, so it's a negative 1 times 2 root 10. Negative 1 times 2 is a negative 2 square root 10. 26. We have two binomials. We solve this the same way we always do when we have binomials. We take first times the first, outside, inside, and last. So the first times the first is 2 times 3, which is 6. Outside is 6i. Inside is a negative 12i. Last is a negative 12i squared. All right, we combine like terms. We can take 6i and subtract 12i and get a negative 6i. This number over here, a negative 12 times a negative 1 is a positive 12. So 6 plus 12 is 18. So 18 minus 6i. 27, we're going to try that same process again. First times the first is a negative 35. Outside is a negative 20i. Inside is a negative 35i. And last is a negative 20i squared. So combine like terms. This number becomes a positive 20 because it's a negative 20 times a negative 1. So a negative 35 and a positive 20 make a negative 15. 20i minus 35i can be added to make a negative 55i. There's 27. 28, these ones are even easier. All you're doing is combining like terms when you add or subtract. So it's 7 plus 2i, distributing the negative, minus 8 minus 5i. So 7 and a negative 8 make a minus 1. 2i and a negative 5i is a negative 3i. You simply combine like terms. 29. A negative 10, and you're adding 3. That gives a negative 7. 4i plus a negative I makes 3i. Combine like terms. All right, we have to rationalize the denominator because we can't have imaginary numbers. So the way we do that is you multiply both top and bottom by I. Because in the denominator, I times I is I squared. And remember, I squared is the same thing as a negative 1. In the numerator, I times I is I squared, and a negative 4 times I is a negative 4i. So, I squared is the same thing as a negative 1 minus 4i divided by a negative 1. You could leave your answer like this, or you can divide everything by a negative 1. A negative 1 divided by a negative 1 is a positive 1. Negative 4i divided by negative 1 is a positive 4i. So I will accept either of these answers on the test. On this one, to get rid of the imaginary numbers in the denominator when there's a binomial, again, you got to multiply by the conjugate. 3 plus 2i. 3 plus 2i. So when you do that, in the denominator, your imaginary number should be gone. 3 times 3 is 9. Outside, 3 times 2i is 6i, but 3 times a negative 2i is a negative 6i, which cancels out. And then a negative 2i times a positive 2i is a negative 4i squared. So there's still an I in the denominator, but remember, it's an I squared, which turns into a negative 1. In the numerator, 6 times 3 is 18. Outside, 6 times 2i is 12i. Rats. There we go, 12i. Inside, 5i times 3 is 15i. Last times the last is 10i squared. Okay, now we're going to clean up some things in the numerator. This is the same thing as a negative 10. It's 10 times a negative 1. So 18 and a negative 10 make 8. 12i plus 15i is 17i. This number is the same thing as a positive 4 because it's a negative 4 times a negative 1. So 9 plus 4 is 13. There's the answer for that question, 31. 32, we're going to solve by getting x squared by itself. Subtract 11. So x squared equals a negative 6. Square root both sides. So x equals, when you square root, you need both plus and minus. The square root of a negative 6 is a positive 6 times a negative 1. So you could take out the negative 1 as I. Square root 6 has to stay. Plus and minus I root 6. 33, the last one. We subtract 9 from both sides. And we get 16x squared equals a negative 4. Divide both sides by 16 to get x squared by itself. So x squared equals a negative 4 over 16. And that reduces, negative 4/16 is a negative 1/4. All right. And now we take the square root of both sides. So x equals, the square root of 1 is 1. The square root of 4 is 2. The square root of negative 1 is I. And when you square root, you need both plus and minus. So plus and minus the square root of 1/2 I. Let me know if you have any questions. If you understand all of these questions, you'll do a great job on the test for tomorrow.